looking at completing the square. And the point of completing the square is to write your quadratic in vertex form, which comes from perfect square trinomials. So remember that perfect square trinomials are the trinomials that can be factored so that you have the same factor 2 times. And to identify a perfect square, you take the square root of the first term, the square root of the last term, you multiply those together. So in this case it would be 2x and 5, which would be 10x, and then you double it to get 25. Or in this last example, the square root of 9x squared is 3x times 6, which is 18, and then you would have 18 double, which is 36. But the difference here is that one is a negative sign instead of the positive. But when we force things into a perfect square trinomial, it allows us to solve quadratic equations algebraically. And so it actually will work for any quadratic equation. So factoring only applies to things that are factorable. Using the inverse algebraic steps only worked when we had quadratics that didn't have a middle term. We can graph and solve most of them, and of course quadratic formula works for all of these. So to create a perfect square trinomial, you're going to take half of your b value and square it. So for example 1, your b value is the coefficient in front of the x, so it would be 14. 14 divided by 2 is 7, and 7 squared is 49. So I would force that to be a perfect square trinomial, x plus 7 times x plus 7. In example 2, half of 20 is 10. 10 squared is 100. 3, it's a negative, but half of negative 4 is negative 2. And when I square that negative, I'm still going to get a positive 4. For this last one, it's going to look a little trickier because, again, what we're doing is taking half of the b value, dividing it by 2, and squaring it. Well, I don't have a nice even division, right? 5 divided by 2 is 2.5. But we can still square 2.5. And 2.5 squared is 6.25. I had that up here, but then I second guessed myself. So the number that would complete the square here would be 6.25. So that's all we have to do to create a perfect square. But if we're going to use this to solve equations, we have a couple other steps that we have to include. So the first thing that we're going to do is move all the constants to the same side of the equation. So anything that doesn't have a variable attached would be on one side of the equation, and we would have our x squared and our x together on one side of the equation. Then we're going to do what we were just doing in the previous step. We're going to divide b by 2, and then we're going to square it. After we square it, we're going to add it to both sides of the equation. So remember that our algebra rules still apply, that we have to keep the equation balanced. So we have to add it to both sides. Then we're going to factor on the side that has the perfect square. We're going to write it in a perfect square form. We're going to combine like terms, simplify the constants. And then we're just going to solve algebraically. We're going to take the square root of both sides, because remember, to undo a square, we take the square root. And then the last step is to find both solutions, because when we find that square root, we have to remember to take the plus and the minus. So let's see what this looks like here. So for step 1, I'm going to move 20 to the other side so that I have 8x and x squared together, and the 20 is going to be on the other side. Now when you're working, sometimes what I will do is I will leave myself room and I'll draw in a little blank, because that's just a reminder to me that I'm getting ready to complete the square, and I draw one on the other side because, again, that reminds me that what I do to the left, I have to do to the right. So then we're going to take the b value. I'm going to change colors here to show that this is kind of like side work. So b is 8. So 8 divided by 2 is 4. And 4 squared is 16. So that's the number I'm going to add to the left and to the right side of that equation. Okay, so we have to make sure that we put it in both places there. So the next step is to factor the perfect square. So again, the whole point of this was that I could write this as the same thing together. You're actually going to want to write it with your squared sign, but just remember that that first row up there is simply factoring x squared plus 8x plus 16, and then 20 plus 16 is 36, so this equation is 36. So now that I have this in this form, the nice thing is I can solve this algebraically by taking the square root, because remember your square root cancels anything squared. But on the right side, we have to remember we have a plus and a minus. So we're going to end up with just x plus 4 on the left because the square root and the square cancel each other out. And then on the right, plus or minus 6. So to find both solutions, we're going to say and move the negative 4 to the other side. And so our two solutions would be negative 4 plus 6, which is 2, and negative 4 minus 6, which is negative 10. So those would be our two solutions to that quadratic by completing the square. So remember, just like when you were doing quadratic formula, it's possible to have one solution, no solutions, no real solutions, because actually with completing the square, we could get negative or imaginary solutions, and then two solutions. So a couple more examples. So x squared plus 6x minus 18. So the first thing that I'm going to do is move the 18 to the other side. And remember that we said I'm going to put that little blank there, so I remember that I'm completing the square. So add 18 to the other side plus whatever will complete the square. So again, you might need space over here till you get a little more comfortable with this. So we take the b value, which is 6, and divide it by 2, which is 3, and then 3 squared is 9. So I'm adding 9 to both sides of the equation. So now the left side is a nice factorable perfect square that we can factor with the rule that we learned about factoring perfect square trinomials. And then on the right side, 18 plus 9 is going to be 27. And then we're going to take the square root of both sides. This cancels, and then we have a plus or minus. So x plus 3 is equal to the square root of 27. So we actually have a little more scratch work to do here because, and I left off my plus or minus. When I get ready to do this last step, so I'm going to subtract 3 so that x is by itself, I have a radical that I'm going to need to simplify. So we can do a little more scratch work over here. So remember that we are looking for factors of 27. So 3 and 9, and we keep going until we get down to primes. So this group of 3's is going to leave the radical. The other one is going to have to stay under the radical. So our two answers are negative 3 plus 3 radical 3 and negative 3 minus 3 radical 3, because we are going to rewrite that one as 3 radical 3. So those are our two solutions here to that quadratic equation. All right, example 3. Again, we're going to add 4 to both sides. And I'm going to leave a place to complete the square. And do that on both sides. So half of 4 is 2, and 2 squared is 4. So that's the number that's going to be added here. I'm going to do that on both sides. We're going to factor the left. That's a perfect square. X plus 2 equals 8. Take the square root of both sides. We're going to subtract 2 from both sides. And we have a little bit of work to do with the 8 because that needs to be simplified. So 2 and 4, 2 and 2. And we can actually leave our answer using the plus and the minus. You don't have to take and separate them. Those would be our 2 answers. All right, if you want to pause the video right now, you can go ahead and try this last one. And then when you're ready, you can start the video again and listen to my explanation. So for this one, you should have added 1 to the other side. And then we're completing the square. So -2 divided by 2 is -1. And when I square that -1, it's a +1. So anytime you're completing the square, you want to make sure that you're always adding a positive number, because it doesn't matter. If it's a negative in squares, it's going to be a positive. If it's a positive squared, it's going to be a positive. So if you ever have a negative number there in that blank, you just want to kind of take a step back and look and see if you can find your error. And then we're going to take the square root of both sides. And it's a radical 2, so I don't have anything to simplify. So the last thing would be just to add 1 to both sides. And so that would be our 2 solutions. Again, you may have taken them and written them out separately, which is fine as well.